Hey everybody. In this video we're going to be talking about factoring by grouping. So I will show you guys how to factor with the method of grouping. There are two ways of doing this. I'm going to try to teach you guys both of those ways, some of them whichever way you prefer. You can go ahead and do it that way afterwards. This is assuming that you've already done the factoring the greatest common factor lesson. So the GCF. If you already did all that in those assignments, and this will be perfect for you because there's really nothing, well, or not that much stuff that you're going to be learning that's new, but you are going to be utilizing the whole factoring out the greatest common factor in this lesson. So if you haven't watched that, you should go ahead and watch that before doing this lesson. Okay, so this is factoring by grouping. So first of all, just a reminder on what factoring is in general. So the word factoring is the act of breaking things apart into multiples of each other. So the act of undoing the multiplication of two binomials. In this case, when we did greatest common factor, or I should say in the last case when we did greatest common factor, we took something out of something or a polynomial. For example, like you can take 2x out of x plus y. Just a little quick example. And in this example, you can see that we have a monomial, meaning one term, that we take out of a binomial, or it can be a polynomial, meaning more than two terms. For this lesson, for factor by grouping, you're actually splitting it up into two binomials. So instead of just having 2x there by itself, you would have it split up into, for example, y plus 2x, or like, so yeah, let's go with that. So y plus 2x multiplied by x plus y. That would be the the end product of factoring by grouping. So basically, that's what we're doing here. We're breaking it up into what times what gives you the original problem. So kind of like what we did in the past, except that this time instead of having a monomial as the greatest common factor, we're going to have a binomial multiplied by a binomial as the end product. Okay. So moving on. So factoring by grouping is identified when there are four terms, and this is very important because they're not going to tell you in the future like which way you have to use when you factor. They're basically going to say factor, and it's your job to see that it is actually four terms. And since there are four terms, more than likely you're going to be factoring by grouping. So essentially what we're doing here, if you guys already know how to multiply with the box, we're basically putting the stuff inside of the box and figuring out, okay, what goes on the outside of the box. So since we already know what's on the inside of the box, how do we know what goes on the outside of the box? And the answer to that question lies in factoring out the greatest common factor. But before we do that, let's go through the steps. And again, if you need to pause this video at any time to write down the steps in your notebook, you can feel free to do that. So step one, you need to draw a 2x2 box, kind of like what you see up there. Then after, you have to group the terms so that there's a common factor between the first two and the last two terms. That's why it's called factor by grouping, because you have to group the terms so that they're next to each other. If they share a factor, the ones that are next to each other. Step two is place each of the terms in the 2x2 box from left to right and top to bottom, kind of like you're reading a book. Step three, take out the greatest common factor from each row and each column. We've done that in the last lesson. And then finally, basically write down the answer on the outside of the boxes, and you can write it as a binomial multiplied by a binomial. Okay, so it's actually not, if you already know how to do the GCF, this is actually going to be pretty simple for you, but I will still show you how to do it several different ways. Or actually, I'll show you two methods, but at the end of this lesson, so you can see the second method in case you see it online somewhere expressed differently, even though it's actually the same idea. So example number one, factor the following expression. So they want us to factor this out, and it is x to the power of 3 minus x squared minus 25x and then plus 25. So the first thing you need to do is check the first two terms. Do they have a common factor between those two terms? As you can see, the answer is yes, because they both have x's. Here I can take out x's from both of these. Let's check the next two terms. Can I take something out of those two? The answer is yes, because you can actually take out a 5 or a 25, which is the greatest common factor between those two. So now that you know that you can take something out of those two and those two, then you can start writing them into the box. So from left to right and top to bottom, first thing I put the x to the power of 3 here. Then next I'm going to put the negative x to the power of 2 there. Next I'm going to put the negative 25x in the third section of the third box. And then finally, I'm going to put the positive 25. So once you have the 2x2 box drawn, which again, they probably won't do that for you, you're going to have to do it yourself. Then you can put everything inside of the box and try to figure out, okay, what can I take on the outside? So now that you have that, you're going to have to take out the greatest common factor from each row and each column so you can figure out what goes on the outside edges of the box. So on these two, as you can see, you can take out the maximum, or you can take out from both of them x to the power of 2. So I'm going to put x to the power of 2 on the left-hand side. From these two, I can take out a 25. But if you remember from the last lesson, if the first number is a negative, then you should also take that negative on the outside. So I'm going to take it out as x squared minus 25. On the first column, you have x to the power of 3 and the negative 25x. I can take out an x from both of them, and I leave it as positive x. And then finally, from these two, it doesn't seem like I can take anything out except for the number 1, right? Because they both have 1 in common, because 1 you can take out of anything, basically, because it doesn't really change the value. The only thing about that one is that I'm going to also take out the negative, because if you notice, the very first term right there is a negative. So I'm also going to take out the negative for this one. So there we go. The final answer for this, if you actually factor out this by grouping, you get that the two factors, or the binomials that are multiplied together to get the original problem, is x squared minus 25 multiplied by x minus 1. And this will be your final answer. If you don't believe me, you could always multiply this out. So again, you can do the distributive properly, you can do the box. You should be able to come back to the original answer or the original problem. If you don't, then you did something wrong. So go back and check your work. All right, so hopefully that's pretty clear. So example number 2, same exact idea. We want to factor the following expression. So first I'm going to check, do these two have something in common? The answer is yes. You can take out a 9 from both of them. Do these two have something in common? The answer is yes. You can take out an n or an n squared, even better, from both of them. So now that I know that the answer is yes, they're pretty much grouped as they should be. So I'm going to go ahead and put them in the box the same way, from left to right and from top to bottom. So n to the power of 3 goes next, and then negative 2n to the power of 2 goes after that. So now that I've filled in my box, now the whole thing is I have to figure out, okay, what goes on the outside of the box. So we're going to be doing the same thing that we did last time, take out the greatest common factor from each row and from each column. So on the first row, I have negative 9n and then 18. I can take out a 9, but remember that this is going to be a negative 9 because the first term is a negative. On the next one, I can take out an n to the power of 2. On the first column, I can take out an n. And on the next one, I can take out a, looks like a 2. Now, here's the thing. I did say that if the first one is negative, then you should take out a negative, and that is 100% true based on convention. However, here is the thing. If I were to put a negative here in front of the n, would that make this multiplication true? As you can see, that would make this a positive 9 inside, and that would not work. So every now and then you have to go back and check to make sure that the box actually makes perfect sense. It should multiply out to the number on the inside. And if it doesn't, you need to do something to fix that, to mitigate that. For example, here, if I take a negative 9 multiplied by positive n, then I get negative 9n. Here, n times n squared, n to the power of 3, that's great. But here, negative 9 times 2 is not 18. That means that this is going to give me a negative 18, which means that this needs to be a negative on the outside as well for this to be true. So go back and check your box, even though it may seem like, oh yeah, easy peasy, lemon squeezy. You may want to go back and check sometimes, because even though I recommend for you to take out the negative, go back and check to make sure that all the multiples come out to be the correct ones every time. So that's it. Final answer. You just write it in. The order doesn't matter. I can put this back. The first one, I can put the top one as the first one and the next one as the second one. And this will be the final answer. Again, the order doesn't matter. 2 times 3 is the same thing as 3 times 2, right? So basically, you can switch the order if you want. Now, in your math books, more than likely, they probably have the highest powers going first, and then after that, the lowest powers. So this will probably be what you would see in any math book as your final answer, but it's the exact same thing. So just keep that in mind in case you don't see, or in case your answer looks different than the solutions or the book or whatever. Okay, example number 3. Factor the following expression. So let's go back and check to make sure that these are grouped together. So I'm going to go ahead and check these two. Can you take something out of those two? And the answer is yes. They both look like they share a 2 and an x, so that's good. Can we take something out of those two? The answer is yes. They both look like they share the number 8. So now that you know that those two are correct, or those two are factorable, or they're grouped next to each other, then we can go ahead and write it into the box. 4x to the power of 3, 2x squared goes here, 16x goes here, and then positive 8 goes there. Okay, so now that you have that, go ahead. We're going to repeat the process as we did in the past and figure out, okay, what can I take out of this row? What can I take out of this row, this column, this column? So from the first one, I can see that I can take a 2 and an x to the power of 2 on the outside of this. On the next one, it looks like I can take just the number 8 because they both have, they both are divisible. They both can be divided by 8, I should say. On the next one, it looks like I can take out the number 4 on the outside of this. However, if you look back and check, so just remember, that's the thing. If you look back and check at this, would this multiply out to the correct thing? So even though I can take out the number 4 from both of these, go back and check, because a lot of the times, if you just do it the way that we did it with the greatest common factor, it may not be perfectly matching up with the multiples on the inside. So even though I can take a 4 from both of these, I'm actually going to change that into a 2, because 2 times 2 would give me 4. And then I'm actually going to change that into an x. If you notice, now it actually multiplies to everything correctly, right? So 8 times 2x will give you 16x, and then 2x squared times 2x will give you 4x to the power of 3. Okay, the next one. So what do we multiply 2x squared to get 2x squared? Well, that answer would just be a 1. So then 8 times 1 will give me 8. So I think we're set. All you have to do now is write the answer. So this is the equivalent of the binomial 2x to the power of 2 plus 8 multiplied by 2x plus 1. All right, so there we go. That is the second or third example, I should say, when factoring by grouping. I just have one more for you guys, and then that'll be it. So same idea. Go ahead, and first you have to check to make sure that they're grouped together. So let's check to see if these two are factorable. Like, do they both have a factor in common? The answer is yes. They happen to have a factor in common. They both have an a. And then check these two. Do they both have a factor in common? The answer is yes. They both have a c in common. Just don't skip this step, guys, because a lot of the times, sometimes the answer may be no. So like, let me just give you a quick example. If this was like this, a squared minus bc plus ca minus ba. So this is the exact same thing as this problem right here, right? But if I check this one, there's nothing that I can take out of these two. And if I check these two terms, there's nothing that I can take out of these two except for an a. But I need to be able to take something out of both of them to be able to factor it by grouping. So since I cannot take anything out of these two, then I cannot factor it by grouping. I would have to switch some stuff around so that it is factorable on both sides. So just keep that in mind. That first step that I do, don't skip it, because if you do skip it, you're probably going to get stuck when it comes to the box. Okay, so now that everything works out for the problem, let's go back and factor this by grouping. So first one goes there, second one goes there, BA, third one goes there, that is CA, and the last one goes there, which is negative BC. So what can I take out of the row of the box, the first row? It looks like I can take out an A from the first row. What can I take out of the second row? It looks like I could take out a C, positive C. What can I take out of the first column? It looks like I can take out another A. And if you look at it, check the box, make sure everything matches up when you multiply it. And it looks like it does. And finally, what can I take out of these two? It looks like I can take out a negative B. Again, go ahead and make sure that everything matches up when you multiply it out. If it does match up and everything is fine and dandy, then all you got to do is write your answer. The two factors for this are A plus C multiplied by A minus B. And there you go, guys. You have now mastered factoring by grouping. Now, if you would like to see a different method of doing so, I will show you guys how to do it here. I know that there's some students that always like to look at different ways of doing stuff, and sometimes they don't want to waste a lot of space on their paper, whatever. So I'll show you guys how to do it on this section of the screen. So a squared minus ba plus ca minus bc. Same exact process. You still have to do the whole checking to make sure that the first two terms and the next two terms are actually, you can take something out of both of those, and it looks like the answer is yes from the last part. So what you do in the next step is literally take the greatest common factor from the first two and the last two terms. So for the first two, I can take out the letter A, right? So I'm going to put A there, kind of like what we did in the box. And then it looks like I have A minus B remaining. So great. Now we move on to the next one. What can I take out of these two? It looks like I can take out a C or a positive C. So I'm taking out a C from this one, and it looks like I have the remaining of A minus C. Now, the method of factoring by grouping is, since you have the same common factor between these two, what it is you are grouping these two into one single term, and you're grouping these two into another single term, meaning that you're going to have two binomials multiplied with each other. One of the binomials is, oh wait, did I mess up? Oh yeah, it looks like I wrote something. Sorry about that. Looks like I wrote a C instead of a B. Whoops. So when I factored out the C there, it should be left with A minus B, not A minus C, obviously, because I took the C out. My bad. Okay, so back to here. To write the final answer, we group the red terms together, A and positive C. So I'm going to write A plus C. And then we group the terms that are underlined in yellow together, which is A minus B. So it is multiplied by A minus B. If you notice, it is the exact same thing as the answer that we have on the right-hand side when using the box. So either way you want to do it, it's fine by me. I just wanted to show you both different ways. That way, if you want to use this method better because you want to save some space on your paper, be my guest. All right, I hope this was useful. Hope you have a wonderful day. If you have any other questions, let me know.